Our today's topic is solution of electronic circuit with super mesh involved using mesh current analysis. Here, let's quickly go through the circuit here. You can see there are two voltage sources like 3 volt and 12 volt, and similarly certain resistances and one current source. So whenever there is a current source in a between two meshes, uh, technique is slightly different. What we have to do is we have to ignore this current source and consider it like an open circuit. By doing so, we will be combining two different meshes. Here you can see there is mesh 1 and there is mesh 3. When we replace current source with open circuit, there, then we will get a super mesh, which is, I have drawn it here. In this equation, you can see there are three current loops I1, I2, and I3, and fourth unknown parameter I0. So, in order to resolve this circuit, we will be having four different equations and four unknowns. By applying mesh current analysis, we will determine values of I1, I2, I3 current flowing through in this loop, and I0, which is flowing through the resistor 20 ohm resistor. Now come to first equation. We have to write mesh equation of loop 1 and mesh super mesh we have just created. So first we are going to write the equation of mesh 2. You can start from any specific point. You can see I have started writing equation from here. The first circuit element we encounter is 5 ohm. So this is V5. Similarly, next there is a voltage source. There is a voltage source 12 volt, and then when we come here, there is V15 ohm plus finally V20 is equal to 0. Here we have applied KVL, Kirchhoff's voltage law, and according to Kirchhoff's voltage law, the algebraic sum of voltages in a closed loop is always 0. That's why the right hand side we have 0 in our equation. Okay. Now come to resolution of this equation. By Ohm's law, we know V is equal to IR. We are going to apply this Ohm's law on our first equation. Here you can see V5, 5 is the resistance, and current flowing through it is I2. You can see here that I2 is flowing across 5 ohm resistance. So we will have 5I2 plus current voltage of 12 volt. Here is 12, and then the next circuit element is 15 ohm resistance multiplied by what will be the current flowing through this 15 ohms resistance. In order to determine, basically there are two currents. You can see arrow towards downwards, and in adjacent loop there is an arrow in the upward direction. The net current we have taken we are dealing with I2 right now. So I2 I2 for I2 for 15 ohm resistance will be the net current, which is I2 Okay, now we are going to find the current flowing through this 15 ohm resistance. In order to determine, we have to understand that with reference to I2, the current is flowing towards down direction, and adjacent loop current is going towards upward direction. We are dealing right now with I2, hence we can say that since current is going in a counterclockwise direction, it's downward. So you can assume that I2 is greater than the adjacent loop current. Hence, we will write I2 minus I3. So this current will be flowing through this 15 ohm resistance. Here I have written 15 into I2 minus I3. 15 is resistance and this is current flowing through this resistance. Similarly, the next circuit element is 20 ohm resistance. Here is, you can see, 20, and the current flowing through it will be I2 minus I1, just like I2 in this direction and I1 is in opposing direction. So the net effect will be I2 minus I1. You can summarize it just like whenever you are dealing with I2, you have to write I2 as a positive and all other loop currents which are in opposite direction as negative. Here you can see I1 is opposing current, it's negative. I3 is opposing current, it's negative. Now see, by applying simple mathematics, we can solve this equation. This is our equation 1. Now come to second equation. We have to apply our KVL to our super mesh loop we have just created. Super mesh is our is starting from this point. You can start from anywhere, but I am taking it as a reference, b not as a reference point, and then we will encounter 10 ohm resistance with 20 ohm resistance, 15 ohm resistance, and 3 volt power 3 volt voltage supply. So just apply KVL to that loop, b 10 ohm plus b 20 ohm plus b 15 ohm plus b 3 volt is equal to 0 according to KVL. And now putting values, 10 ohm resistance multiplied with I1. Here you can see I1 is flowing through this 10 ohm resistance, and what current will flow in 20 ohm resistance. Now we are dealing with I1, that's why we will keep I1 positive and I2 negative. Here you can see I1 is positive, I2 negative. 20 into I1 minus I2 plus next resistance is 15. You can see current flowing across 15 ohm is I3 minus I2. Now you might get confused in why we are considering I3 when we have created super mesh. Just to be clear, super mesh is for resolving the circuit. We did not actually replace this element with open circuit. We are just doing this for the sake of easy resolution of circuit. So we will be actually dealing with three currents, I1, I2 and I3. Okay, now this KVL equation is written here. You can solve it by simple mathematics. 10 I1 plus 20 I1 is 30 I1 minus 35 I2 plus 15 I3 is equal to minus 3. We have two equations now. At the start, I've explained that there are four unknowns, I1, I2, I3 and I naught. This is I naught. So we will be getting four different equations. But the problem is we have four unknown variables with two equations, one for I2 and second one for super mesh. So what we are going to do is we will apply KCL at node A and node B. What is node A and node B? We can see here we have to find I naught flowing from node A towards 20 ohm resistance through 20 ohm resistance. We name it as a node A, and at B we have a current source which was replaced by an open circuit element. So we will name here, we will consider this node uh, for solving the circuit. By applying KCL at node A, we can apply in a manner current entering is equal to current leaving. You can see here at node A, I naught is leaving, and with reference to I2, it's leaving, and with reference to I1, current is entering. Hence, we have two currents leaving and one current entering. You can write here I1 is equal to I2 plus I naught. This is the KCL equation at node A. Okay, now you can see here we have written KCL equation. I naught plus I2 is equal to I1. Rearrange it to determine I naught as our primary parameter to determine is I naught. Okay, now apply KCL at node B. Let's explain it here from the diagram. In node B, you can see that there are three currents entering or leaving. Uh, with reference to I1, the current is leaving from node B, and current I3 is entering, and 2 ampere current is also leaving from node B. So you can write I3 is equal to I1 plus 2 ampere. It's KCL at B. Got it? Now go to our notes. Go back to our notes. You can see KCL at node B. I3 is equal to 2 plus I1. Now by applying KVL on our mesh and super mesh and KCL at two nodes, we now have four different mathematical equations, that is equation 1, equation 2 obtained from KVL, and equation 3 and 4 obtained from KCL. Now we have to solve these four equations to determine these four unknowns, that is I1, I2, I3 and I0. For the time being, do not consider this equation, just we have three equations with three unknown variables I1, I2, I3, and this equation also have I1, I2, I3, and this equation has I1 and I3. So this solution is pretty simple. What we are going to do is we are going to put value of I3 in equation 2 and equation 1. In that way, we will get equation 1 and 2 in terms of only I1 and I2. Means we will be having two equations with two unknowns. Two equations, two unknowns. Okay. Here put value of equation 4 in equation 1 and 2. You can see we will get following these equations. Putting a value of I3 in equation 1, we will be getting this equation, we name it equation A, and putting equation 4 in equation 2, we will be getting equation B. Now we will solve equation A and B using subtraction method, which is quite simple. Getting ready for subtraction method. Equation A, 35 I1 minus 40 I2 is equal to minus 18. So divide whole equation by 35, we will get this equation I1 minus 1.14 I2 is equal to minus 0.52. And similarly equation B, we will simplify it by dividing it by 45 on both sides. We will get these equations. Now what we are going to do is we are going to subtract equation 2 from equation 1. Here is a subtraction. We can see we will get I2, which is 0.589 ampere. By putting value of I2 in any of these equations, we will be getting value of I1. Here you can see we have put value of I2 in this equation, here I2, and by solving we got I1 is equal to minus 1.19. Now we have two equations, we have two values of two unknowns, which were I1 and I2. What we are going to do is we are going to determine use remaining two equations, which are equation 3 and 4, to determine value of I3 and I0. I3 is equal to 2 plus I1. Simply put value of I1 here, and you will get value of I3. And after getting that, you can put value of I1 and I2 in this equation, and you will be getting value of I0, which is actually required in our statement. Here comes the remaining part. Here I3 is equal to 2 plus I1. I3 is equal to 0.81 ampere. You have to write unit along with it. Don't forget it. And similarly, using equation 3, we will determine value of I0, which is minus 0.60 ampere. I forgot to write ampere. Please don't forget this, as in examination forgetting the unit will result in deduction of marks. Now since we have all the loop currents, we have value of I1, we have value of I2, we have value of I3 and I0. So in that way we can determine values of power dissipation, voltage drops across each resistor by using value of I2, which is flowing through 5 ohm resistance. We can easily calculate power, which is equal to VI, or you can use V square over R, or you can use P is equal to VI. You can use any method out of these. So you can calculate power dissipation. Here you can calculate voltage drop, which is V is equal to IR. You know about the value of resistance. You know about the value of current flowing through this. You can calculate voltage drops. But here we have to determine I0. I0, what value we got? I0 is equal to minus 0.6. But it means why it's negative? It's negative because we have assumed the direction here towards this direction. Now if current becomes negative, it means that the actual flow of current is in the opposite direction. So you can say that since its I0 is equal to minus 0.6 and its arrow is in this direction, so the flow of current is actually 0.6 ampere in this direction, opposite. While direction is not a point of concern here, we just need value of I0, which we have determined. I0 is equal to minus 0.6 ampere is your answer. Thank you so much.